Intercepts. Intercepts in graphing are really important. Okay, so intercepts tell us a lot. So first of all, let me make sure you guys know what an intercept is. An intercept is the point of any function that has been graphed, any equation that's been graphed, that crosses either the y-axis or the x-axis, right? These are intercepts of the axes. So here's where this line crosses the y-axis. Here's where it crosses the x-axis. Pretty basic, right? That's the point that crosses the x. That's the point of the graph that crosses the y. This is called the x-intercept because it intercepts the x-axis. And this is the y-intercept. Intercept basically means crosses. So let's do a couple. You have to remember that all x-intercepts have a coordinate that looks like this. Some number that we call x, comma, 0. The second position, the y value, has to be a 0 in order for that point to be considered an x-intercept. Just the same thing for the y, but only reversed. The x value has to be a 0. So all y-intercepts have the same leading x coordinate of 0, comma, some number. So now that we know that, let's try that on a different graph. There's our buddy, the parabola. So I'm looking at this thing, and I can see two x-intercepts. All right? One right there at -5, the other one at 1. And because of the rule, I know the y value is going to be 0, so I know 2 points of that parabola right off the bat. All right? -5, comma 0, 1, comma 0. So remember, if you got a 0 in the y or the x position, that means you're talking about an intercept, including 0, 0, right? The origin can be an intercept for both of the y and the x-axis, so don't let that confuse you. But now let's look at the y-intercept on this one. That's right there, right where it crosses the y-axis, and that looks like -2, 0. No, see, I tend to do it all the time myself. It's 0, -2, right? Y-intercepts start with x equals 0. So it's 0, -2. Now let's try this on a funky graph, something like that. Let's see, 1, 2, 3. This would be a quartic function, x to the 4th something. You take the number of times it changes directions going up and down, and you add 1, and that's your highest exponent of the function. So I can see all kinds of x-intercepts on this bad boy. 1, 2, 3, 4. Again, that tells you that it's a quartic function. Quartic is to the 4th. If we list them all out, you'll notice they all have zeros in the y position. Remember that. If you see a 0 in the y position, you're talking about an x-intercept. And it only has one y-intercept, but that's going to give us an x value of 0. Okay, 0, comma 3. If you have a y value that's a 0, whatever this other number is, regardless, could be 0, that point will be an x-intercept. I'll say that again. If the y value is 0, whatever the x value is an x-intercept. And just like the y-intercept, if your x value is 0, that following number is your y-intercept. And that too could be 0. So 0, 0, the origin is the only point that could be both the y and the x-intercept at the same time. I'll say that again. The origin can be a y-intercept and an x-intercept at the same time. See, that 0 stuff is just constantly causing problems. MGZ, out.